Shout out to Marie, Caroline,
Michael,
Eric, Mackenzie, Abby. Yeah.
bingo.
Shout out.
Okay, let's get started. So I want to solve this equation. Cosine of 2x equals sine of x. Any ideas?
Yep.
What?
1 minus sine of 2x.
Why did you pick that one? The other side had sine in it, so if I'm going to solve this equation, I need to have all the same trig functions if at all possible.
Right.
So if 0 on one side, I would go to the right. Does everyone know why I would do that? We don't like negative, right? And this is factorable. It's a hard factoring problem, but it is factorable.
Oh.
But it has a leading coefficient, so you have to think about the inner and outer terms, however you do that.
2x minus 1.
Good. 2 sine of x, and then sine of x, and then 1 and 1. I do need. Good, because I need the 2 to be positive and the 1 to be negative. See how I got that? Questions about it?
Nope.
Set both pieces equal to 0. And so I get 2 sine of x equals 1, sine of x equals half, and sine of x equals negative 1, and what was that? 0 to 2 pi. When is sine negative 1?
3 pi over 2.
And when is sine half?
10 over 6 minus 6 pi.
If you get stuck, draw a picture, right? So it's the 30-degree angles in quadrants 1 and 2, and you are correct. Pi over 6 and 5 pi over 6. Any questions about that one? Now, all of the ones so far that you've had that have had a double angle in them have been ones that really were beneficial to get rid of the double angle and solve it a different way. Well, today we're going to look at how can we solve one if we have to deal with a multiple angle. So that's what we're going to be looking at today, is solving equations with a multiple angle involved. So I have sine of 3x equals negative 1. Though I could break sine up, if you remember correctly, if I break it up, it gets pretty nasty. Now remember that? And so I would rather not. So I'm going to work with the multiple angle as it sits. So I want to know, when does sine equal negative 1? What does sine equal negative 1?
3 pi over 2. 3 pi over 2.
So I'm going to write it like that. 3x just needs to equal 3 pi over 2. Wouldn't that work? If 3x is 3 pi over 2, then sine would be negative 1 over 2, right? Here's one problem. I am trying to solve, well, sorry, we'll do. Read directions. Instead of 3 pi over 2, what am I going to put? 270. Okay, before I finish this, I want to make sure I'm not missing any answers. Right now, I'm trying to solve where x is in the interval 0 to 360. Does everyone agree? Where would 3x be?
Between 0 and like 360 times 3.
Right? Does everyone agree?
1080.
So does everyone agree that to get all of the answers, once I divide the 3 out, I'm going to need to go around the circle more than just one time? Because when I divide, let's try it. So the 270 is the only answer I got the first time. But let's go around the circle 2 more times. So add 360 to 270, so give me that answer.
363.
630. And does everyone see where I got those? Those are just coterminal angles, right? Maybe I don't need them. I don't know. But I have a suspicion that I'm going to need them. Because what's x? How do I get x? I know 3x. And so what's 270 divided by 3?
330.
Are all of those still between 0 and 360? Do they all work?
How did you know? Okay.
So, this is the new stuff for the day. You have multiple angles, you have to go farther out, possibly.
So why would you have to farm out?
So, would you agree that if x, it told me x has to be between 0 and 360, right? That if I multiply everything in that interval by 3, that means 3x has to be between 0 and 180. So, I need to go all the way to 180. Because when I divide that 3 out, then I'll be between 0 and 360. So every time I have one of these, I'm gonna do this thought process and go, okay, how far do I need to look first to put my angles when I divide in the...
Would you always have to do that?
Now you will get to where you do that in your head, but yes, you always will have to make that thought process. How far do I need to go? Quick question. What if this is a half x?
You need to go.
Then you'd only have to go half as far, right? Because then you'll double this, and we'll look at that every time. Okay, any questions about this answer? So that's the new stuff for the day, working with multiple angles. So now if I can get the trig function by itself, even if it has a multiple angle in it, I'm going to work with it. It's going to be easier. If I were to change this, then I'd have a sine squared involved, which there's nothing wrong with. But it would be a little bit more work, everyone agree? So I'm just going to work with cosine of 2x. I'm going to ask myself, first of all, how far do I want to go? Right now my interval is 0 to 360, so what does that mean my interval will be when I multiply by 2? So 0 to 720, so I'm going to go around the circle 2 times. Everyone agree? And I'm doing degrees on this first few, maybe the bottom one I might try radians just so you can see it, but the radians would be the same. If you're going from 0 to 2 pi, then you would go from 0 to 4 pi, right? You would go around the circle twice. Whatever you need to do to get the angles. And we'll do some examples of radians also. A lot of your problems on your homework will start with a different interval from 0 to 360. It may even only want answers from 0 to pi over 2. But again, do this quick little decision on how far does that mean that I need to go. So I want to ask myself, when is cosine equal to radical 3 over 2? I need to draw a picture. Maybe you might know, but cosine is positive when?
First.
First and third. Cosine is adjacent over cosine is adjacent over hypotenuse. Does everyone agree? Those are 30-degree angles. So 30, 330. Oh. 30, 330, 390. Where'd you get 390?
At 360.
And
690.
690. Does everyone agree with where I got those numbers? And then how will I find out?
How much is it? 15. 165. 195. 345.
So everyone got any questions about that? Okay, let's look at the next one. What am I going to have to do before I start with the x over 2? Get a cosine by itself. Just like when the angle was a single angle, I'm going to have to get the trig function by itself. So divide by 8. 4/8 is 1/2. Square root both sides. What do you get when you square root things?
You get plus or minus, you get 2 answers.
Okay, with root 1 and the square root of 1 is just 1. I'm not going to rationalize it. Normally I would, but since I'm trying to go back and find the sometimes it's nicer to draw a picture if it's not rational. So I'm going to leave it as it is. I'm going to go think about my interval. Again, this does not have to be written on paper. I'm writing it for today because it's a notes day and I want you to see my brain thought process. This is something that you will start to do with your head. The original interval was from 0 to 360. So where would half? I would divide all of those by 2, right? So that's between 0 and 180. So I'm not going to look all the way around the circle like I normally would. I'm only going to look in the first 2 quadrants. If you accidentally looked all the way around the circle, when you multiplied by 2, you'd have to cross out some answers because they would get to be bigger than 360. Does that make sense? I'm going to draw my picture. Normally I would go in all 4 quadrants, but since I'm only going from 0 to 180, I'm just going to do the first 2. But that would be all 4 quadrants. So it's 45, 45, 90. So 45 and good. Any questions so far? So then what would x be and how would we find that? Multiply everything by 2. So normally we divide, but this time since we are divided on the left, we will multiply by 2. Check it, right? See if you're doing a good job. 90 divided by 2 is 45. Cosine 45 is root of 2 over 2 or 1 over root of 2. I would square that and I get 1/2. 1/2 times 8 is 4. So you can check those to see if you're getting good answers. Any questions about those? Do you see why 270 is the last option? Anything bigger than that, when I multiply it by 2, would get it outside of 0 to 360. That interval part might be the hardest part. Okay, let's look at this one. There are 2 ways to work this, and after today, even on today's homework, I don't care how you work it. I am going to force you on this problem to work it with double angles. You could just change sine and cosine or vice versa. So after today, you have options on this particular problem, but I'm going to get you thinking outside the box a little bit with a multiple angle. Cosine squared minus sine squared. Does everyone see a cosine squared minus sine squared there? What is cosine squared minus sine squared? Isn't this cosine 2 theta? So 2 cosine 2 theta plus 1. I have a single trig function. It's a different way that I would have gotten a single trig function yesterday. Again, this problem has 2 wonderful ways to work it. This is just another option. Again, you don't have to use double angles. Use whatever you want. But now they're an option. They weren't an option yesterday. Yesterday I would have tried to get rid of double angles because I'm good. Questions so far? What do I do now? I'm trying to solve this from 0 to 360, so what am I going to do? Where am I going to look? 0 to 720. Everyone know why I'm going 0 to 720? Twice as far. Multiply the whole interval by 2. Cosine is negative in the second and third quadrants. Jason over hypotenuse. 1, 2 radical 3 triangle. Those are 60-degree angles. Everyone agree? I want you to note how I'm doing this because I know right now you've got your unit circle memorized really well, and so you might just know the answer. But when you're in calculus and you haven't thought about the unit circle in a while, there is no shame in drawing this picture real quick. Okay? So do that if you need to get yourself back to where you know those answers when you've forgotten. Right now you can probably do a lot of these in your head. You're probably like, why is she drawing these pictures? Part of it is to remind you what to do when you don't have it memorized. Where to go. going around twice because the interval was 0 to 360. When I double that interval, I'm going to get 0 to 720. So 480 and 600. All right. Divide all of those by 2. Questions? Feeling pretty good? Double angle, multiple angle. Gosh. I hope you know this already. I hope we've talked about it enough already. But you cannot get rid of a double angle by dividing out of 2. Remember that 2's trapped inside the cosine function, so the only way to change that is by using an identity. So just mental note that. Here. Okay. Let's do this one. I'm going to give you a minute to move this one. This is stuff. Give you a minute to look at it first. So now we're getting into some ones like yesterday's problems that get tricky, but now we can deal with multiple angles if we want to. We don't have to. We could change them into regular angles if it's easier. I know no one's had time to finish it. Has anyone gotten any ideas on where to start? Anything we could do?
Cosine from sines.
Okay, change it to sines and cosines. Is that what you did also? Okay, change everything to sines and cosines. It's an option. It's the only option. We'll work with that one first. See if we can they already have common denominators, which is nice. So you can go ahead and write that as cosine of 2x minus 1 over sine 2x. No.
Mark out the denominator.
I could if the right side were 0. Since the right side's not 0, I can't just mark it out. I could cross multiply though. If I don't want to get rid of the denominator. So cross multiplying or common denominators, however you did that now for 2. And what? Try to use an identity. The double angle identities probably aren't going to get me anywhere because you're going to have sines and cosines. Can't use a Pythagorean theorem because squared, I can make them squared. Couldn't I? And speaking of, and I'll finish it this way because that's what you thought of. But if you had rearranged from the beginning, plus 1 equals cosine squared. Identity up there. Down here, when we square both sides, which one are we going to end up using? Cosine squared of 2x minus 2 cosine of 2x sine squared of 2x. Change the sine squared into what?
One minus cosine squared.
Mental note on this step. What red flag should I throw up in my head when I square both sides? So I'm going to mental note at the end. I need to check answers. As I square both sides, it's always a good idea to check answers, but this requires that I check answers because I remember I forget extra answers. 0 on one side. Add the cosine squared over, so I get 2 cosine squared of 2x minus 2 cosine of 2x minus 0. We agree? Ones cancel out when I add the subtract one. Factorable? Greatest common factor of 2 cosine 2x factors out. And now I can set x is equal to 0. Which that's just cosine of 2x equaling 0. Divide the 2 out, right? And cosine of 2x equals 1. So, yeah, right. Interval. Let's talk about interval first. It says 0 to 2 pi. I think it said that. So when I double the angle, I'm going to go 0 to 4 pi. So I'm going to go around the circle 2 times. And this is the first one we've worked in radians, so you'll get to see how the math works out with the radians going around again. When is cosine 0?
0
5 or 2?
3 pi over 2.
And 3 pi over 2. And what about another time around the circle? What am I going to add to both of those? 2 pi. And since it's over 2, I'm kind of adding 4 pi over 2 to both of them. Does everyone agree? If I want to add 2 pi, that's the same as adding 4 pi over 2. Okay, so I'm adding 4 to the top 2 numbers. It seems at first glance like radians is going to be harder, but it turns out the actual addition may be easier because you're going to deal with smaller numbers. You have to deal with common denominators, but once you take care of that, 5 pi over 2 and 7 pi over 2. And then it seems like that the division, it's got to be harder because we're in radians. But what happens when you divide by 2? What do you do with multiply the denominators by 2? So it just ends up that these are all pi over 4s. So it turns out we got all of the pi over 4 angles around the circle one time is the solutions to that part of the equation. Does that make sense? And when does cosine equal 1?
0 and 0.
Just at 0, right? Now I am going all the way to 4 pi. No, let me check my endpoint on this really quick, make sure I wasn't wrong. Yeah, the 2 pi was not included in the endpoint. Why do I feel the need to check that on this part?
One of the answers could have been 2 pi.
One of the answers could have been 2 pi, but it's not going to be. So my 0 and 2 pi, I am going to include it at this point, right? going to include that. Does everyone see what I mean by that? So just 0 and 2 pi, divide both of those by 2, I get 0 and pi. Unfortunately, what do I now have to do?
Change that.
Okay. I'm going to go back to the original equation because what if I messed up, right? So I want to go back to where I haven't messed anything up. Cotangent 2x, cosecant 2x. Which one? Mine was minus cosecant 2x. Okay, so cotangent. Won't this end up being a pi over 2? Does everyone agree? Cotangent of pi over 2 is 0. Does everyone know how I guess that? Any questions about that before I? So cotangent of pi over 2 is 0. Cosecant of pi over 2 is 1. It's the reciprocal, right? Of sine. Does that work?
Yeah.
Why not?
So it makes it negative.
It's the wrong sign, right? And remember, that's the kind of error we expect. It's a sign error. Does everyone know what I mean by that? If I have anything more than just a sign error, I probably need to go back and check my work. I probably messed something up. But the squares, they only get a sign. Does that make sense? Sign as in positive, negative, not sign as in S-I-N-E, sign. Pi over 4 didn't work. 3 pi over 4 times 2 is 3 pi over 2. So cotangent of 3 pi over 2 is also 0. Cosecant of 3 pi over 2 though is negative 1, right? And what's minus a negative 1? Positive 1, that works. 5 pi over 4 becomes 5 pi over 2. Right? 5 pi over 2, yes. Yeah. Okay, so 5 pi over 2. What was that? Okay. Between 0 and... Yeah, okay. 5 pi over 2 and 5 pi over 2, isn't that quadrantal with pi over 2? Just run out the circle again. So it's going to act exactly the same as the pi over 4 did. Does everyone agree? And 7 pi over 4 is going to act just like the 3 pi over 4, so there's really no need to check both. That makes sense. 0, this one does work. Cotangent of 0 is undefined. Does everyone agree? And cotangent of pi is undefined. Doesn't work. Now, I will tell you, if you had worked this from the original that way, you would have gotten a 0 to pi. We lost that they were undefined because we only looked at sine and cosine, didn't we? We ignored that it was cosecant and cotangent to begin with, and we just worked with sines and cosines. So we got some extra answers from that as well. So there are really only 2 answers. Any questions about that?
You worked before.
Yes. Okay, so that would be pi over 2 when you put it in. Cotangent of pi over 2 is 0. This is the point, 0, 1. Okay. And then cosecant of pi over 2 is 1 because sine is 1 and the reciprocal is 1. That's negative 1.
Okay.
Not equal. This is about as hard as they get. This was a tough one. It had identities and squaring both sides. So that was a messy one. Your homework, and I am finished with the lessons. Tomorrow is a birthday. 352, those numbers, and a worksheet. I got that first page done by tomorrow just because I want to help you finish your workout. So do that. What did you say that? How many problems was that, Alice? 5 problems. We can make that. We can do 5 problems.
Then you said the front page of the worksheet.
Do what?
You said the front page.
No, in the worksheet is too much. Tomorrow's the work day. I want the bookwork
is that our review or are we gonna get?
You're not going to get another review. Now, I can give you more review problems if you want to, but I'm not going to require another review. Since we've only done the lesson for 4 days, I don't feel like we need to go back. You know what I mean? I feel like we just got more.
Do Monday.
Do Monday on the work. Tomorrow is a work day.
What do you know?
Your table.
When's the test?
Yes, and while the video is still recording, I know I told all of you this, but be quiet so I can tell everyone who's watching on video. This is a very short chapter. We're just doing solving trig equations. It'll be another 50-point test, and it will be on Tuesday. Wednesday, we're going to take our mastery exam, and I'll give you a copy of that tomorrow, the blank copy of the mastery exam tomorrow. Wednesday next week, we will take our mastery exam for the first time. That will be due before Thanksgiving, so Monday before Thanksgiving, last day. That's everything I told you.